Hello and welcome back for lesson 9.1. We are nearing the end of the semester and we're just going to look at a couple last sections so that you're exposed to some new concepts and ideas. And 9.1 kind of goes back to circles, which we touched on very little in chapter 2. And I'm going to share my screen. This is our book. So in chapter 2, we touched on the circle a little bit, and I'm going to go over that equation just to kind of show it to you. I really just want you to be exposed to these different shapes. And so the shape that we're going to look at today in 9.1 is called the parabola, which we did that shape when we graphed the quadratic equations back in like chapters 5 and no, back in chapters 4. 3 or 4. So it says if the plane is perpendicular to the axis of the cone, so we've got these two cone shapes that come together, and the two halves are called naps, and they intersect at this vertex point, okay? And it says if the plane is perpendicular to the axis of the cone but does not pass through the vertex, the cone is a circle. The conic section is a circle. So we're going to look at the conic section called a parabola, okay, in this section. 9.2 is going to be about the ellipse. And ellipse is similar to a circle, except for it looks a little bit more like an egg. And then 9.3 is going to be touching on the shape of a hyperbola. Okay, so the idea of a parabola is that we have a point focus, this focus point 0, P, and we have, and that is on this axis that is vertical and then makes a perpendicular to the directrix, which is this line down here, y equals a negative p. And so you can see that we want to form an equation, this parabola, this pink line is the equation, such that the distance from that focus point, 0p, is always the same from a point P on the parabola to the directrix. So you can see that these distances from 0 is point F to point P is the same as point P to point M. And so as we were to move around on this parabola, we would always be the same distance, always corresponding from the parabola to the focus, and then the parabola down to that directrix. And if you're going on into the calculus sequence, you'll be using these more, but I just wanted you to expose to them. And so because those distances are the same, we can use the distance formula to find the distance between F to P to F has to be equal as the distance from P to M. And so the distance from P to F is calculated here. So x minus 0 squared plus y minus p squared. And then the next line is the distance from P to M. And then when you set those distances equal to each other, you're going to square both sides to alleviate the square root. And then when you combine like terms, it comes out to be x squared equals 4py. So we're going to do a couple examples. This is when the vertex of the parabola happens at 0, 0. Okay, so that's what's setting up there. So some of the characteristics of a parabola. So the only ones that we looked at earlier in the semester were face up and face down. So the situation here, which is the vertical axis of symmetry, okay? Then there could also be a horizontal axis of symmetry here on the right-hand side. And so that equation is gonna be y squared equals 4px. So we've got some characteristics of each here. We're gonna use the p to tell us if it's face up or face down. And then on the right-hand side, we're going to use the P to tell us if it's face to the right or face to the left. This is assuming that our vertex is at 0, 0, and the focus is at 0, P. And so that means P is the distance from the vertex of the parabola up to the focus, and also the distance of the vertex of the parabola down to the directrix. That's that distance P. And then the directrix is at the line y equals a negative P, or the line x equals a negative P, depending on the which way your parabola is facing. So let's look at a few problems just with this basic one where the vertex is at 0, 0. Okay, so we could have these two equations. So if the x is squared, you know it's a face up or face down, and if the y is squared, you know it's a face left or face right. And I kind of just wrote down for us the characteristics when the vertex is at 0, 0. So let's go ahead to page 746 in your book and look at 11, 12, 13, and 14. I thought it would be good for us just to get familiar with what they look like and how the visual graph looks compared to the equation. So before we make our guesses, let's just go by the squared. So x is squared in number 11. So we know it's going to be an up or down. And the x is also squared in 13. So it's also going to be an up or down. And on 11, I'm guessing it's an up because the coefficient on the x squared is positive. And even if you divide to put that coefficient on the left, it's still going to be positive. So I'm guessing it's going to be an up. And on 13, the coefficient on the y is a negative. So I'm guessing it's going to be a down. So this is just my initial guesses before I even look at the graphs in the book. 12 and 14 are both y squared. So they're either going to be a face right or a face left. And 12 is a positive coefficient. So I think it's going to be a face right because that's when P is greater than 0. And 14, I think is going to be a face left because the coefficient is negative. So that's just my initial guess there. So let's look at the graphs. So they're all, you can see the parabolas all have a vertex at 0, 0. And I would definitely say 11 is going to be face up. And it's definitely going to be C. We can also see that we can tell that because, again, like I said, from the coefficient here. So 11 is C, and then 13 is going to be the face down. So that one is going to be B. And then 12 is going to be the face right. So that's going to be D. And then 14 is going to be A because it's facing left. So this one is D and A. Okay, so let's move on to 15. So problems 15 through 38 say find the vertex and focus of the parabola that satisfies the given equation. Write the equation of the directrix and sketch the parabola. Okay, so 15 gives us this equation, y squared equals 12x. So because it's y squared, we immediately know that it's left or right facing. And because this is positive, it's going to be a face right. So I'm just kind of giving myself a visual there. Okay. And because we know the coefficient on x is equal to 4p, so 12 is equal to 4p. And if we divide by 4, we can see that p is equal to 3. So our focus is going to be at P0, which is going to be 3, 0. So our focus is at 3, 0. Okay, and we know our vertex is at 0, 0. Because if you put in 0 for x, y is 0. Okay. And they want us to find the vertex in the focus. Oh, whoops. So the vertex is at 0, 0. And the directrix is going to be the line of x equals a negative p. So x equals a negative p. So x equals a negative 3. So we're going to go 1, 2, 3, and it's going to be here. And then write the equation, sketch a parabola, which we did. Okay, number 19. So this one is a y equals x squared. Okay, so x squared, so we know it's going to be either face up or face down. And I'm going to get this so that it's in the form where x squared is alone. So I'm going to move this coefficient to the other side by multiplying by a negative 4 over 1 so that those cancel. So I'm going to multiply by negative 4 over here. And so we get that. Okay. So because P is our coefficient here, the negative 4 is equal to 4p. P is equal to a negative 1. And because P is less than 0, we know it's the face down. And we know our vertex is at 0, 0. Because there's no shifting going on inside the x squared or the y. So the vertex is at 0, 0. So the focus is at 0p because it's the x squared. So it's 0p or 0, negative 1. 0, negative 1 is the focus. And so that means that distance is a 1. So that means this is going to be at a 1. So x, so the directrix line is at y equals the opposite of p, so at 1. So that's right here. So there is the directrix, and then it's going to be face down. And we're actually used to seeing it in this format to tell us some things, because this is our standard format for the quadratic equation, and that negative would also tell it's face down. And our vertex is at 0, 0. So it's kind of cool to see it in a different light. 23, asking us to do the same thing. So I'm going to get, it's the y squared. So we know it's going to have this format here to tell us about the directrix and the focus. So I'm going to get y squared by itself by dividing by 5. So y squared is 4 this X. So we know that 4P equals 4/5. And so if we divide by 4, we get 1/5 is P. So our focus is at P0, or because it's a y squared, it is, sorry, because it's a y squared, it's going to be P0 is our focus. And so it's going to be at 1/5 0. And our vertex is at 0 0. And because P is greater than 0, we know it's going to be to the right. And so the focus is at 1/5 0. So it's just here. And the vertex is there. So then the directrix is going to be at the line of X equals a negative P, or X equals a negative 1/5. So it looks like that. Okay. Next up is going to be parabolas that have a vertex that's not at 0 0. Okay, they're going to have a vertex at H and K. And we also looked at this when they were in the vertex form. So similar to this, except for our A basically, right, is not quite in this form because our H and K were on the other side. It was in a little bit different form than this, but this is going to be the equation that we're using for these parabolas. Our H and K are still our vertex of H is the X coordinate and K is the Y coordinate. We're still using P to tell us if it's face up or face down, or face left or face right. The focus is going to be at H, and then the offset by P for K on the up and down ones, and then on the left and right ones, the H is going to be offset by P. And then our directrix is still going to be a line Y equals or X equals, but it's going to be offset by P as well, because the vertex has been shifted. So we're going to keep this handy for us here. So we're going to look at number 27, still looking for the vertex and the focus, and then the line of equation for the directrix and the sketch of the parabola. So 27, our vertex, we can see is 5 is H, because this is the X squared piece. It's going to be this one where it's face up and face down. And then this is really subtracting a -1. So K is a -1. Let's just draw what this is. So this would be 1, 2, 3, 4, 5, and down 1 is my vertex. Okay. And because this piece here is negative, it's going to be face down. Okay. And so our -4 is equal to the 4P. So P is equal to a -1. And so our focus is at H and K plus P. So H is 5 and K is a -1 plus a -1 for P. So it's at 5 and a -2. So 5 and a -2 is our focus. And then our directrix is the line at y equals k minus p. So y equals k is a -1 and p is a -1. So a -2. So it's at y equals, oh, I think I was supposed to add. K is a -1. Oh, subtracting, sorry, subtracting, so that becomes a positive. I was like, wait, it needs to be up here. So it should be at 0. So that should be our directrix. Sorry about that. So it's a -1 subtracting a -1. So it becomes a -1 plus 1 is 0. Okay, 28. So 28, this time it's the y piece that's being squared. So it's going to be a left and right facing. It's the y piece. So let's just draw our graph up here, and let's start with the vertex. So this is subtracting a -3. Remember, it has to be a subtracting for it to be in the form that we need it to be in. So this is going to be subtracting a -2. So our vertex is at a -2 because it's the 8. The H is on the X, so it's a -2. I've got them flipped in a -3. So 1, 2, and then 1, 2, 3 down. And then 8 is equal to 4P, and so P is equal to 2. And so since P is greater than 0, it's going to be facing right. And so this is our vertex. So it's going to go something like this. I don't know exactly what, but I do know that our focus is going to be H plus P comma K. So H is a -2 plus P comma K is a -3. And we know the focus has to be over in here anyway. So that's at 0 and a -3. So 0 and a -3 is our focus. And so this distance here is 3. So you know it's going to be 3 over here for our line, right? For our directrix. So our directrix is going to be the line at x equals, wait, this is 2. One, 2, sorry. This is 2, so this is going to be 2. So this is going to be at a -4. Everything for 28. Okay. And then how about we look at (42). 42, this section says, determine the equation in standard form of the parabola that satisfies the given conditions. So 42 says, we know the directrix is at y equals 2, and the vertex is at 0, 0. So we're going to be, it's going to be, the directrix is at y equals 2. So because it's a y equals, it's going to be this format here. So it's going to be this format, okay, because it's the directrix is at y equals 2. So because y equals 2, we know that the director says that y equals a negative p. So equals a negative p. So that means that p equals a negative 2. And so if p equals a negative 2, then x squared equals 4 times a negative 2y, or x squared equals a negative 8y. So there's our equation. Is that how they wanted? Yeah. Okay. And then, last but not least, I'm just getting you exposed to this, is one more of these, where the vertex is at 0, 0. Okay, so 44. Vertex is at 0, 0, and the focus is at 0, negative 3. Okay, so the let's just draw what this looks like here. So vertex at 0, 0, focus is at 0, negative 3. So it must be a face down, right? So it must be of the same type that we were just doing. So it's going to be an x squared equals 4py. And because our focus is in 0, negative 3, we know that p must be a negative 3. So it must be x squared equals 4 times a negative 3, whoops, y. So x squared equals a negative 12y. And if we wrote this in our form that we used back in the earlier chapter of quadratics, we would actually have it as y equals a negative 112x squared, because that's how we looked at it there. We looked at it in the form of solving for y. So that is all of the concepts that I'm expecting you to be familiar with for your homework for chapter 9. And I'm not going to be putting chapter 9 on the final exam, but there will be a few homework problems due for chapter 9.1. Catch me back for some interesting little tidbits on 9.2.